Hi, and welcome to my science room. Hey, I'm so glad you're here today. There's some really important things I want to talk to you about in this class. The first one is why science is your most important class. And after that, I'd like to tell you a little bit about why science is important, and then finally, what exactly is science? So, first of all, I'd like to just go over some things about why science is just so important to learn. Most of the world's technology was based on science. Anytime we're addressing a societal issue is built upon knowledge for humanity. This is really based on science. Solving everyday problems, informing the government, satisfying our curiosity. Did you know that economics is 1/3 to 1/2 of our whole U.S. economy is based on our research from science. So our growth and our economy are directly linked into science. Everything from energy to phones to clothes to even the food you eat is really based on science. So if we're providing energy, security, curing illnesses, everything from all the way from the beginning of time till now, we are based on our progress on science. So science is really important to understand this, and really understanding that our standing in the world is based on our science. Now, you might think that's great and all, science is important, but why is it important for you? Let's think about this a little bit. Now, in today's success, we're looking for a path that will bring you personally success. Did you know that the highest paying jobs in the United States are all based on science? So really, what you do for a living and how you're going to make a living is really one of the things that makes science so great, and another reason why this class, science in particular, is your most important class. Now, it would be nice to say that English or social studies are going to get you a high-paying job, but that's not really true. Today, in our economy right now, the highest-paying science jobs to make a lucrative living, let's just look at some of those. Let's just take a wildlife biologist. Do you like animals? It's about $67,000 a year. That's starting salary. How about a geneticist working with DNA and being able to tell people about their background and their heredity? Starts at about $78,000 a year. Or how about a biomedical engineer? That's good and up there about $98,000 a year. Or let's just go straight to something like microbiology, learning how to look at a microscope and recognizing things like this. This is about $97,000 a year. I'm talking top paying jobs. From there, I can go to the most lucrative science jobs, the ones that have the top salaries. Let's look at your average physicist. $131,000 a year. You like that kind of money? Am I getting to you now? It's sort of like, why is science important to you? It's because that's where the jobs are. A chemist, about $117,000 a year. That's the starting average when you get out of a 4-year university. I'm not talking about master's degrees or PhDs. These are your average jobs that you can get out there today. Pharmacology, when you go to the pharmacist, those are about $126,000 a year. So why is science important to you? Not only is it important to our world, but it could be very important to your future. So listen up. Let's take a look at those jobs and realize that in this United States economy right now, 4 million jobs are just based on chemistry. It's true. You want to get a good job? Think about science being your most important class. So if this is actually true, what is actual science? If I put on a lab coat, does that mean I'm a scientist? Does that mean I'm doing science? If I put on a pair of goggles, does that mean I'm really doing science? How about this cute little graduated cylinder? Or how about this nice big beaker? Am I doing science now? How about, oh, I like this little cute thing. How about this little one? If I'm using this, am I doing science now? Or, oh yeah, test tubes. This makes me doing science, right? What is science? Yeah, we use this equipment in science, and hopefully you will be using some of this when you get into our labs. But let's really talk about what is science. So, first of all, science is knowledge gained through experience. So you experience things, you understand that this is something that's happening, and when I go out into the mountains and I want to know the flowers and the trees and I want to know what they are, I bring along a little field guide, and after a while I don't need the field guide anymore. I know that's a Douglas fir, or I know what kind of flower that is. So I'm going to gain that through experience, that science. Another thing about science is that it's really an accumulation. It's a collection. It's a body of knowledge of this physical and material world that we live in, which is so important to understand. And through our observations and what we see and our experiments, this is really what science is. That we accumulate this knowledge, and throughout time we have accumulated this knowledge, not from just science, but from a lot of different aspects. Now, most of all, really, science is fact. How we get that fact is through scientific method. But those facts or principles are gained by a systematic study. So I know that gravity exists because throughout time we have systematically studied the principles. That it's not just a theory. These things have been proven over and over again. So let's take a look at a really simple experiment. I bet you've done this before. Let's take two different substances and put them together and see how they react. That's science, right? So let's take a look at this. In my flask here, I have a substance, and it is acetic acid. You might know it as vinegar. Here's our balloon, and in here I have sodium bicarbonate, or soda, just average soda. I bet you know this experiment. Now, when I put these two together, I know from knowledge that I have gained that this is going to make a gas. And that gas is called carbon dioxide. So let's take a look. I'm going to put this right down on here, and let's see how it goes. Okay, and here we go. Carbon dioxide. I made carbon dioxide. Now, it's it's pretty much well known that this is carbon dioxide, and if I pull this off here, I have carbon dioxide in this balloon. When I let it out into the air, it mixes with all the other elements, and we have more carbon dioxide in the air. There it goes, carbon dioxide. So, in order to understand what is science, we really need to assume some things. We need to say, yeah, these things are true. So we're going to assume some of the following. In order to know what science is, you have to assume that there is order in this universe, that it isn't random, that things don't pop out of nowhere. These things are important to understand because we assume this to understand what really science is. And as a human being and our human minds, we're capable of comprehending this order. And this way we can understand logic, which is really what a lot of science is based on. It's logical thinking. You understand it in science, you understand it then in English. You understand it in science, you understand it in social studies. It goes out to all subjects. So in this understanding of science about what it is, we have to also assume that the human mind is capable of understanding and comprehending this order that belongs on Earth. It doesn't change every day. It doesn't change in 100 years. It stays the same. So what is science? Is this accumulation of order that we have figured out in our minds. So, if conditions are the same, and we believe that there is order on planet Earth, then the results, what happens in every experiment we do, and in any study that we do, is the same. So again, let's go back to the experiment. I know that I can repeat this experiment. I can take my acetic acid. I can take my baking soda, and I know for a fact that this experiment will turn out the same way. Let's try it again. My variables are the same. I have the same things going on. When I pull this up and I put that on there, I get the same results. Whoa. It's really going off this time. I'm still making carbon dioxide. This is a proven fact because I can repeat this experiment over and over again, and I still get the same results. How about if I change one of the variables? Let's try it just a little bit, okay? See if it's the same, okay? So this time, I'm gonna try it right here. And again, I've got my substance, acetic acid, and I've got my baking soda. Let's try it this way just for fun. Okay, and put it down there. I hope this turns out because last time I did this, it popped. Let's try this. Do I still get carbon dioxide? Oh, yes, I do. Take a look at that. I still have the same results. This is really what science is. That I can get there the same way, and I can count on that, and it's done over and over again. You don't want, if you can't do that, if I can't repeat another scientist's experiment and get the same results, then it's not science. Let's take a thought here. Let's say somebody figures out the cure for cancer. And I take that same experiment and I do it and I can't repeat it and it doesn't work. That's not science. It has to be proven and it has to be able to be repeated. So, what is science? Let's take a look at some of these statements and see which ones you think we could actually figure out, because when you're talking about science, science has to be able to answer certain questions, and there's certain questions that we can't answer. How about this one? Most of the energy coming from the sun is in the form of visible light. Now, could I test that? Sure. I could have a spectrometer. I could see if it was visible light or microwaves or ultraviolet light. Yeah, I could test that and I could figure out and prove that question. What about this one? Shakespeare wrote great plays. Now, this is based on opinion. I love Shakespeare. I think he did write great plays, but you may see a Shakespeare play and say, I didn't understand that and I don't like it. So I can't prove that. It's based on values and opinions. How about this? The Earth is about 4 billion years old. Yeah, I could prove that through radiometric testing, through finding out the radioactivity of certain elements, I can certainly test that and prove to you that the Earth is indeed 4 billion years old. How about this one? Unicorns are real. Now, I've never seen one, have you? But they might be out there. Maybe we haven't seen it. There was an interesting study done by some ornithologists, some bird people, and they said, hey, we found an animal we haven't seen this animal, we thought it's gone extinct. And then when the scientists went out there to see if that bird really did exist, they couldn't find it. So in a way, it has to be able to be repeated. How about this one? Diamonds are more beautiful than rubies. Again, I can't prove it. It's based on opinion. I personally think emeralds are the most beautiful gem. So unless I can prove that, it's not a good question for science. Now, I could prove diamonds are harder than steel. I could take the Mohs hardness test and I could scratch the diamond with the steel and it wouldn't scratch. But if I took the diamond and scratched the steel, I could definitely prove that diamonds are harder than steel. So, what makes good science? What makes you a good science student? What makes scientists exhibit these good traits? First of all, curiosity. Now, you may think, oh, science, I've been doing that for so long. I've seen it all, done it all. But really, your curiosity is what makes science fun and exciting. Having an open mind. Being able to understand that even if you didn't get that before, you're going to open your mind up and be able to see this again. Asking good questions is everything in science. Having a good question, that's the key to what science is really about. Hey, the other thing is honesty. You've got to be honest with science. If something that you see and you don't agree with, but you see this, you have to be honest. You have to be honest about making mistakes in an experiment, even if your data isn't good. Otherwise, it doesn't mean anything. You need honesty as a good scientist. And here we go with a lot of problems that sometimes people have in this world is willingness to be wrong, willingness to make mistakes, and being able to recognize that that is a mistake or we did it wrong. In the end, what a good scientist really is all about is having skepticism. Now, you may not understand what this might mean, but it really means that you're able to doubt things. So it would be sort of like if a policeman doubts something or has skepticism about something that somebody says. You need to be able to do that as a good scientist. Question what you see from all angles. So today, I'm really excited for you to understand what is science. We've gone over why science is really important for you. We've gone over why science is incredibly important for the world. And most of all, we've gone over really what science is. I hope you've enjoyed your lesson today. Thanks for being here and thanks for your time. Bye now, signing off for the Science Classroom.